Assalamualaikum warahmatullahi wabarakatuh. I'm Hidayah binti JULAIHI from Department of Petrochemical Engineering, Polytechnic Kuching, Sarawak. Today, I will present to you about column sorption studies for oil removal from palm oil meal effluent POME by using esterified sago bark. Objectives of the project: first, to conduct esterification of sago bark as a sorbent named esterified sago bark (ESP) for oil removal in POME. Actually, POME is stand for palm oil meal effluent. Second, to study the batch adsorption by using ESP on raw POME at room temperature on different bed heights and different particle size of sorbent, and by controlling the inlet flow rate of the POME. Third, to determine the oil and grease content in POME after going through the oil adsorption process. Okay, this is process flow of design. First process is preparation of the sorbent. Second, esterification of sago waste. Third is psychochemical characteristic. Before psychochemical characteristic, there is preparation of the sorbent must be done. Okay. Psychochemical characteristic consists of FTIR analysis, SEM analysis, and hydrophobicity analysis. Fourth is sorption study. Okay, sorption studies include bed height analysis, particle sizes analysis, and flow rate analysis. And last process is oil content in POME, where the oil efficiency or removal efficiency is calculated. Okay. Oil from POME according to Ibrahim et al. Palm oil meal effluent POME is a thick brownish viscous liquid waste which is non-toxic but has unpleasant odor, which contains soluble material that may have a significant impact on the environment. Palm oil meal effluent is a waste produced from the palm oil processing plants, according to Ahmad et al. Okay, according to Wahi et al. 2013, adsorption and coalescence of mechanisms are often studied, although there is a very high probability that both mechanisms occur simultaneously. The advantages and disadvantages of adsorption is shown in the table, where the adsorption process, the advantages such as good oil removal efficiency, simple operation, and low processing cost. The disadvantages of adsorption process such as labor intensive, poor removal of fine emulsion less than 100 micrometer, according to Lee et al. And Ahmad et al. Respectively. Okay, the diagram shows accumulation of the sorbate molecules on the sorbent surface. In the adsorption process, molecules of the sorbate accumulate on the sorbent surface without penetrating into the sorbent, according to Ahmad et al. 2005. Adsorption is a preferred oil removal and relatively lowers processing costs in comparison to other oil removal technologies, according to Ibrahim et al. 2009. Many studies have been conducted on methods to improve the oil removal efficiency of natural solvent by means of alkalization of chloroform treatment, acetylene, salt treatment, and esterification. Many esterification studies of natural fibers were conducted via acetylene in the presence of acetic anhydride, according to Gebran and Sebe 2007. Esterification is one of the widely used chemical modification to increase oil removal efficiency of natural fibers, according to Telly and Valia 2013. Okay, the preparation of sorbent sago bark. First, the sago bark was washed with double distilled water. It was dried in sunlight for several days, and dried materials was grinded by using laboratory blender and screened by using laboratory sieve to different particle size of 500 micrometer and 1000 micrometer. As you can see in the figure 2A to B, okay, figure 2A showed dried sago bark, figure 2B showed grinded sago bark. Okay, the synthesis of esterified solvent, ESP. Sago bark was placed in the bottom of the column containing ethyl acetate, and it is esterified with addition of stearic acid to chemically modify the performance of sago bark through esterification process. Stearic acid was added for performing the reaction. preparation of sorbate, where palm oil meal effluent was stored at 4 degrees Celsius to maintain the concentration of solution. Filter paper is used to ensure no solid particle or suspended solid content in the solution. Then the filtered POME is stirred until it is mixed well and kept in plastic bottle. Preparation of sample for Fourier transform infrared spectroscopy. Sample 1 consists of potassium bromide (KBr), where the method of preparation of KBr powder sample is generally to determine the chemical or physical stability of the sample. And KBr powder is grinded with agate mortar until it was dispersed and formed as fine flour. The latter is then pressed into a dish. B. The preparation of raw sago bark (SB). The preparation of raw SB sample is generally to determine the alcohol or H group in raw SB by using FTIR spectrometer. Sample 3, the preparation of esterified sago bark ESB is generally to determine the ester CO group in ESB by using FTIR spectrometer. Okay, about batch mode oil adsorption test of palm oil meal effluent, it is conducted by using ESB on raw POME at room temperature and conducted by using chromatographic column. ESB were used as adsorbent and filled in the column based on different bed heights, particle size, and controlling the inlet flow rate of the POME. RSM model maximum numbers of run order is 10 experiments. The minimum experiment were conducted is 8 experiments. Okay, to determine oil content in palm oil meal effluent, it was conducted by enhexane solvent extraction method. The measure weight is taken as oil and grease content value, and the oil removal efficiency is the mean from the equation below. As you can see, the formula of oil removal efficiency, CO minus C over CO times 100%. CO is initial oil concentration of POME in milligram per liter, and C is final oil concentration of POME after filtration. The characteristic of esterified sago bark was conducted by using three methods: FTIR, spectroscopy analytical method, scanning electron microscopy (SEM), and hydrophobicity test. The objective of response surface morphology (RSM) is to study the effect of variables and their responses by running minimum number of experiments according to JULAIHI et al. 2013. Then experimental runs were employed, and from the results of ANOVA summary, it is about 96.92%, which implies the probabilities of run 7 is more significant. The figure shows the esterification of sago bark ESB, where sago bark contain alcohol group and alcohol and carboxylic acid, stearic acid, react to produce ester and water H2O. Esterification process is done by using oil bath heating method. As you can see in the figure, there is sago bark in different sizes were esterified in 4 hours. ESB was washed with ethyl acetate once the heating process is complete. This is esterified sago bark ESB looks like, and this is sago bark. Oil and grease content were determined for raw POME before adsorption and POME after adsorption. As you can see in the table, shows pH value is 4.3, oil and grease content is 70,000 milligram per liter. The table shows the final oil concentration of POME samples run number 1 to run number 10. The highest oil removal efficiency is 98.69% by run number 7. And the bed height is 15 centimeter, flow rate 5 milliliter per minute, and particle size is 500 micrometer. After hydrophobicity test was conducted, it was found that esterified sago bark had the highest oil removal efficiency in palm oil meal effluent with 98.69%. It can be observed that esterified sago bark ESB was able to repel water compared to sago bark SB. SB shows the high tendency to repel water compared to SB. SEM analysis was conducted to compare the surface morphology of sago bark before esterification and esterified sago bark before adsorption. Figure 1 shows the relatively smoother surface of sago bark, and Figure 2 shows the rougher in esterified sago bark with formation of pores. Analysis of FTIR spectrum of the ESB showed the spectra demonstrate that ester was successfully grafted onto ESB. Figure 1 shows the result of infrared spectrum of raw sago bark. Okay, the alcohol stretch is between 3,400 to 2,400. Figure 2 shows the result of infrared spectrum of esters in esterified sago bark ESB. And desorption studies were carried to evaluate the performance of esterified sago bark in removing oil and grease from palm oil meal effluent POME at the minimum and maximum uptakes 5 and 15 cm of bed height, 500 and 1000 micrometer of particle sizes, and 5 and 15 ml per minute of flow rate. According to Shavandi et al. Reported that due to higher contact time and higher adsorbent surface area, the results were in higher adsorption capacity. This is one of the effects of adsorption bed height. The table shows the effect of different bed height of esterified sago bark with the low flow rate and high flow rate. At run number 7, bed height with 15 centimeter showed the highest oil removal efficiency, which is 98.69%. At the high flow rate, run number 9, by using 15 centimeter bed height, showed oil removal efficiency with 82.80%. The graph shows the bed height of 500 micrometer particle sizes, and this is the bed height of 1000 micrometer particle sizes. And now, effect of the absorbent particle sizes. According to Amott et al. 2013, the smaller absorbent particle size offers a comparatively larger and more accessible surface area. As a result, higher adsorption occurs at equilibrium. The graph shows the highest oil removal efficiency by using 0.5 millimeter particle size compared to 1.0 millimeter particle size. The table shows the highest oil removal efficiency is 98.69% were obtained at low flow rate 5 milliliter per minute compared to high flow rate 15 milliliter per minute. Okay, it's time to conclude my presentation. Sago bark as a sorbent named esterified sago bark ESB successfully produced by esterification to obtain higher oil removal efficiency in adsorption of grease and oil in the palm oil meal effluent POME. The ESB is found to effectively absorbing oil in POME at the slower flow rate of 5 milliliter per minute with the smallest particle size of 500 micrometer and the highest bed height of 15 cm with 98% oil removal. This study showed the small particle sizes of ESB plays an important role. The study also showed the higher bed height of esterified sago bark, the slower the flow rate. Therefore, the low flow rate of 5 milliliter per minute and bed height of 15 cm was selected as optimum condition. This experimental study is quite useful in developing an appropriate technology for treating POME in palm oil industry before being discharged into watercourses. Thank you very much. Thank you very much. Assalamualaikum.